one often is also interested in the average treatment effect for some subgroup. For example, it could be that a drug works better for females than for males. And we have already studied such heterogeneous effects in chapter 1c, and one way would to be just to run separate regressions for each subgroups. One for male, one for females. Alternatively, you could run just a single regression where you add interaction terms. And that was also what the quiz was about. But maybe we are not only interested between the difference of males and females, maybe we have a lot of explanatory variables for a person, like its age, whether it has some previous diseases, whether it has taken some previous drugs and has reacted in some way. So it would be nice to have a personalized treatment effect based on all the relevant or potentially relevant explanatory variables. So more precisely, what we would like to estimate is this conditional average treatment effect tau of x. So this should be the expected value of the potential outcomes of all persons who are treated and have some characteristic x minus the potential outcome of all these persons who are not treated and have this characteristic x, where x is basically just a vector of all possible explanatory variables. And this personalized treatment effect, tau of x, can potentially differ between very fine-grained subgroups. Maybe a drug has only a strong effect for a subgroup, let's say, of older males that have been smokers and had some previous chronic disease before. Now, in theory, we could just run now a lot of separate regressions for all these subgroups, but typically experimental datasets are not so large, and we just don't have enough data points and basically to estimate the effect of any subgroup in a reliable manner. And also we have a multiple testing problem for which we have to account in some way. So, but we probably don't have not enough observations. And just running a single regression with interaction terms basically doesn't help. Then we have so many interaction terms that we have the same problem of not enough information. What would be nice would maybe some estimation method that kind of finds the relevant subgroups where the treatment effects kind of substantially differs. So if it's a treatment effect that works very nicely for older males with some particular chronic disease, it would be nice if the estimation algorithm finds out the subgroups and finds, hey, for this subgroup we have a different effect than for the other subgroups, for example.